Hi there. Uh, Here in this session, I will be explaining the simple concept of calculus. I will start off with the idea of limit that will lead up to the power rule. Okay, let's take a look at this simple analogy of limit. Say I want to predict the shape of a circle using a polygon, and I begin with a triangle. Is this triangle a good prediction of a circle? Of course not. Okay. And next, I increase the sides or number of sides of the polygon. So is square a good prediction of a circle? Of course not, but it's getting better. It's getting closer. So let's increase the number of sides. Hexagon, yes, getting closer to the shape of a circle. Okay, so what we can say is as the number of sides of the polygon increases, then the polygon is becoming closer and closer to the circle. By that, we can say if n is the number of sides, then we can call the polygon n-gon. Then we can make a statement as follows. As n becomes larger, then the n-gon gets closer to being a circle. Or as n approaches infinity, or the number of sides approaches infinity, then the n-gon approaches the circle. So the limit is the circle. Then the mathematical notation is as follows. Lim means limit. So the limit of n-gon as n approaches infinity is equal to the circle. Okay, so that's just simple uh, introduction of limit. And what I will do next is to introduce this term derivative, because we will be using this very often in calculus. So derivative means something that is based on another source. So again, derivative means something that is based on another source. For example, the derivative of cow milk, well, it can be cheese, it can be yogurt, because these two, cheese and yogurt, are based on cow milk. So derivative is something that is based on another source. What about in math? In math, derivative is the slope of the line tangent to the curve. For example, if this is the curve, okay, then derivative is the slope of this tangent line here, because the slope of this tangent line is based on that point there of a curve. So derivative, something that is based on another source. There you go. Okay, now let's take the idea further about the slope of the tangent line. Okay, if you remember earlier, we are trying to predict the shape of a circle using polygon. Now, in this example, I want to predict this the slope of this tangent line using secant line. Secant line is a line that cuts the curve. So again, I want to use secant line to predict the slope of this tangent line. So now let's draw a secant line. Okay, there you go, that's a secant line. And the gradient of the secant line is change in y over change in x. Okay, so this is the change in y, see that, f of a subtracted by f of x, and then divided by change in x, a subtracted by x. So that is the slope of the second line. But this second line is still too far from the tangent line, meaning we have to bring it closer to that, so that it becomes closer and becomes a better prediction of the slope of the tangent line. Okay, now let's bring that second line closer. Okay, there you go. By bringing the second line closer means bring the x point there closer to A. So by doing that, we have a second line closer to the tangent line. Okay, now let's see what happens if we bring x a lot more closer and closer and closer to A. Okay, see what happens when we bring x closer and closer to A. The second line becomes closer and closer to the tangent line. That means that the slope, consequently, the slope of the second line becomes closer and closer to the slope of the tangent line as x becomes closer to A. And in terms of mathematical notation, this then becomes, okay, limit of this slope here. This is the equation for the slope. As x approaches A, yep, because we want to make x becomes closer and closer to A, okay, then we can have the slope of the tangent line. Okay, so let's do a slight alteration. What I want to do, I want to write this expression without A. I want to use h instead. So let's just say the distance between x and A is h. Therefore, A is just equal to x plus h. So I replace A, these A's, with x plus h, x plus h, and I tidy this up. I get this expression here. Okay, so then you can use this formula instead. See that h approaches 0, mean the gap is approaches 0. So you can use this formula to calculate the slope of the tangent line at point A, which is what we want. Okay, so let's take a look. Say in this example here, again we want to use this formula to find a slope of a tangent line at point A or at a given point. Okay, say we have this function y is equal to x squared, and we want to find the slope or gradient when x, that x there, is equal to 2. Okay. So this is the formula that we previously find, and h of course approaches 0 if you remember from the previous slides. And since our function is x squared, this becomes x plus h all to the power of 2 minus x squared over h. Okay, do not replace h with 0 yet, otherwise it becomes undefined. We have to tidy the expression at the top here. Okay. So if you expand this, you get this expression subtracted by x squared divided by h. Simplify it, then you get this expression here. Then these two h's cancel out. Therefore, you end up with this general expression to find a slope at any point on the curve of x squared. So the gradient at x equal to 2, so at x equal to 2 is 4. So this is the gradient function, we call it. Okay, gradient function that comes from this function. Remember the definition of derivative? Something that is based on another source. So this function, to find the value of a gradient at any point on the parabola, come from this original function. So this is the derivative. So again, just to recap, this is our original function, y is equal to x squared, and we want to find the slope when x is equal to 2. Okay, and we have found the gradient function, which is 2x. So since this is the gradient function and we want to find the gradient at x equal to 2, you then replace x with 2. That gives you 4. So this is called the derivative or gradient function, and the symbol is f dash of x, or dy by dx. Okay, let's do another example. When we try to find the gradient function using this formula, that is said that we are using the first principle. Okay, remember, this is our original function x cubed, f of x equal to x cubed. Therefore, f of x plus h is equal to x plus h all to the power of 3. And again, since h approaches 0, we need to replace h with 0, but don't do it yet, because if you do it, you will get an undefined answer. So we have to eliminate this h at the denominator. So expand this expression first. Okay, expand it first and subtract it by x cubed. Tidy it up. You can take out the common factor, which is h, then you can cancel this h. Right? Then you can put h equal to 0 to these two. Then your final answer is 3x squared. So 3x squared is the gradient function of x cubed, or the derivative of x cubed. And you can find any gradient or any slope on any point on the x cubed curve. Right? Let's do another. This time x to the power of 4. You do the same thing, follow the same procedure. Okay. Then the gradient function is 4x cubed. And again, you can find any slope on x to the power of 4 curve using this gradient function. All you do is just substitute the value of x. Okay. So to sum up, if we have an original function of x squared, then the gradient function is 2x. And when the original function is x cubed, the gradient function or the derived function is 3x squared. And when the original function is x to the power of 4, the derived function is 4x cubed. But what about x to the power of 5? I'm sure you know the answer by now. When the original function is x to the power of 5, then the gradient function or the derived function is 5x to the power of 4. So can you see the pattern? and come up with a general formula? I'm sure you can. So this will be the general formula, n multiplied by x to the power of n minus 1. So given any original function, then you apply this formula. It is often called the power rule to find the gradient function or to find the derived function. Okay, lastly, what is a derived function? A derived function is a function whose power has been reduced as a result of changes of y relative to x, meaning it is equal to d f of x over dx. D means delta, okay, which is equal to change. And notice that this is the formula to find a slope. You see, change in y over change in x. And remember, uh, finding a slope is just equal to finding a derived function, right? So d of x to the power of n over dx, so change in y over change in x, is equal to n multiplied by x to the power of n minus 1, and that is called the power rule. And the process itself, going from this one here to here, is called differentiation. There you go, the basic concept of differential calculus, and I hope it helped. Thank you very much.